Hello golf enthusiasts, my name is James Cairns, your resident golf expert. Today I'm going to be sharing with you some applications of physics in the golf world. Now these applications are much more numerous than people seem to realize, and they all begin with your driver and your ball. Now when your ball meets your driver, it generates what's called an applied force, and that applied force will hopefully send your ball shooting off hundreds of meters into the distance. Now it does this by generating a very large acceleration right off of the bat, and eventually your ball will reach a very high velocity. Now, when it's out there in the sky, it will encounter some resistance. One is in the form of air resistance, which is a form of friction. The other is in the form of gravity, which will pull your ball out of the sky down towards the ground, where it could also encounter some friction in the form of grass, for example. Now, this isn't all bad because we can use the force of gravity and other forces in physics to our advantage in the golfing world. Here's an example from Corey Connors. For example, let's take a look at Canadian golfer Corey Connors' tee shot. His high trajectory gives his ball more gravitational potential energy at its apex, causing that energy to release into the green and the ball to stick. In this question, we are asked to find work, and we know that Corey's club has done work on the ball because it has traveled a distance of 181 meters. Now, we also assume that the angle of the club, 28 degrees, affects the ball perfectly so that the ball comes out at exactly 28 degrees. Now, when we plug this all into our solution, we come out with work equaling 3.2 times 10 to the 4 joules. In this problem, I am asked to find gravitational potential energy, and we know that that ball has gravitational potential energy because it is 34 meters above the hole. Now, if the ball were to fall, it would maintain that energy when it hits the hole, as we saw in our first example. Now, if I plug all my given values into the MGH equation here, I would end up with a total of 16 joules of potential energy. Now we are solving for kinetic energy, which is energy in motion. Now, we're solving for the kinetic energy of the ball, and that is dependent on mass and velocity. Now, the ball has a very small mass, 0.049 kilograms, but it is moving at a very high speed. And if I plug those numbers into my equation here, I would discover that the ball has 150 joules of kinetic energy after Corey's shot. Now, in this problem, I'm not given too much information, but I'm trying to find velocity. And according to the law of conservation of energy, I know that initial energy will equal my final energy. Now, when the ball is 2.5 meters above the green, it has gravitational potential energy. And when it finishes, when it's moving, it has kinetic energy. Now, when I plug all my given values in to this equation here, and I rearrange for V, I will end up with the speed of the ball at 7 meters per second right. Now, in this question, I'm asked to find the force of friction. I already know my coefficient of friction between the ball and the grass. I just need to find my normal force. Now, since there is only horizontal motion, not vertical motion, I know that my normal force will be equal to my force of gravity, which is mg. Now, if I plug in mg to my equation, I put in all my variables, I'm left with the force of friction equaling 0.19 newtons acting counter to the motion of the ball, which in this case is left. In this projectile motion question, I'm asked to solve for time. Now, I know that Corey's tee is 42 meters above the green, so I know that I'm really only dealing with the y component, or the vertical component of this question. Knowing that, I can solve my distance equal to the 42 meters. I can sub in the rest of my given values. If I rearrange for t, I'm left with 4.5 seconds of airtime. Here I'm asked to find the normal force. Now, since there's no movement, I know that there are two forces, a normal force and a force of gravity. The normal force acts up on the caddy. It's basically a force exerted from the ground, and the force of gravity acts down. Now, I know that since there's no movement, the caddy is stationary, the normal force will be equal to Fg, the gravitational force, which is equal to mg. If I sub that into equation and sub in my given values, I end up with the force, or the normal force, equaling 980 newtons. In this question, I'm asked to solve for acceleration, or how much velocity Corey's ball is gaining. Now, I have all my given values here. I know the final velocity the ball reaches, the time it takes to reach that velocity, and the distance. Now, if I sub all these values into my equation, I rearrange for A, I find that acceleration equals 81 meters per second right. Well, golf enthusiasts, that's all from me for today. I hope you learned something interesting about physics today, and enjoy your next round.